Cross-layer method of reliable transmission in UAV ad hoc network based on improved AntColony algorithm. Zhang and Zhijun Liu and Mingfei Beijing Polytechnic College of Magnificent Engineer, Beijing 100176, China. Email jamesjlx@163.com. Abstract. In order to improve the quality of communication between VAVs, a cross-layer reliable transmission method based on improved AntColony algorithm is proposed in this study. According to the free space education mode, the threshold of sound strength for receiving messages from neighbor nodes is defined. Then, the improved AntColony algorithm is used to calculate the path stability between the source node and the destination node, so as to preclude the stable of the reliable transmission path of UAV ad hoc network. The running speed of the buffer area is calculated according to the catch calling length of UAV and Hawk network, and the congregation in the transmission process is detected. Finally, through the energy computation and transmission balance mechanism, improve the routing process of data transmission between UAV formations to achieve reliable transmission of UAV ad hoc networks. The experimental results show that this method can effectively reduce the transmission outage probability. With the increase of data transmission rate and UAV speed, lower average delay and higher delivery success rate can be obtained. Keywords: improve AntColony algorithm, UAV ad hoc network, reliable transmission, communication protocol, across layer method. 1. Introducing. At present, the application of UAV has covered many fields such as civil, industry, production, and military. Moreover, UAVs has become an indispensable and important part of model warfare. These are mainly used for tasks such as reconnaissance and surveillance, intelligence collection, communication relay, and rapid strike on the battlefield. The modern battlefield has the characteristics of the high confirmation, wide coverage, and large amount of information. When the military UAV formations perform tasks cooperatively, they can exchange mission planning, fighting status, intelligence information, and other data with each other through UAV self-organization network to improve UAV informant's perception of real-time situation and achieve the overall effectiveness of multiple UAV performance tasks independently. In UAV self-organization network, each UAV is treated as a node. Reference proposed a mutable access control protocol supporting mixed service transmission. Aiming at the QoS requirements of mixed service, the protocol adopts multi-channel random access to transfer the highest priority service, and multi-channel free busy access search for the remaining priority. It controls the access right of non-timeout practical packets in real time, according to the threshold and channel obfuscacy and provides QS guarantee capability for each priority service through a multi-priority back-off me- mechanism based on channel-free busy awareness. Reference processed a multi-priority single threshold access control protocol. By designing a channel load static time prediction mechanism by a channel access control mechanism based on a single threshold, more accurate channel load static and load control based on data package can be each achieved, so that the system channel carriage capability matches the actual channel load and mixes the use of channel resources. Reference proposed a cross-layer optimization technology of using multiple description coding to improve the QS of video streaming applications in multi-radio wireless mass network. WMN is an emerging technology used to correct variable type of networks to the internet. Design of a cross-layer method for reliable transmission of UAV ad hoc network. 2.1 Perceived stability of the reliable transmission path of UAV ad hoc network. It can not only comprehensively elevate the stability of a link, but also predict and delete the link that may be interrupted in advance by receiving the single string of hello messages, and establishing a long-term monitoring mechanism for them, which overcomes the shortcomings of perceived methods and improves the network performance. At the same time, in order to avoid the impact of GPS projection error of internal interface on the method, this paper does not use the location information of nodes. In UAV ad hoc network, due to the rapid movement speed of UAV and different task allocation of each UAV, the network topology changes rapidly, and the performance of link interruption is very common. Therefore, in order to avoid the discretion of network performance cases by link interruption, a link stable evaluation method is proposed. 2.2 Congregation detection and unreliable transmission process of UAV ad hoc network. In the process of information transmission, all through UAV will consistently send the transmitted data information to its net hop UAV. UAV will also continuously receive and transmitted data information from the perceived hop UAV. When the overwrite rate at which the drone receives data information is much higher than the rate at which it is sent, the load on the nodes increases, which will cause compression on the transmission path. By detecting the length of UAV's cache queue, the speed at which its cache area is full loaded is calculated. When the speed of UAV cache reaches full loaded, it is positive. and the faster the speed is, the easier it is for UAV cache to overload. The more likely it's to case concurrency, and the higher the concurrency degree of UAV, the lower the speed is. The lower the concurrency of UAV, when the cache reaches full loaded at a negative speed, it means that the current available cache speed of UAV is larger and no concurrency will occur. 2.3 Realization of reliable transmission across layers of UAV AdHoc network. In view of the larger amount of data transmission between UAVs, only the adaptive power control mechanism cannot guarantee the reliable transmission of data. It's necessary to reasonably select the route of data transmission according to the status of the data link. The follow is an analysis of routing selection from the perspective of emergency computation and transmission balance to realize cross-layer transmission. 3. Experimental comparative analysis. 3.1 Set the experimental fragment. Simulate the information transmission of UAV self-organization network and set a simulation script that multiple UAV are distributed in a 50 kilometer 6 kilometer square area. Other parameter sets are shown in the table 1. 3.2 Analysis of results. In order to verify the superiority of the method in this paper, the cross-layer method based on supporting mixed service transmission descriptive in the reference, and the cross-layer methods based on multi-priority single threshold access descripted in reference are compared. After applying different methods, the performance of break probability varying with a single nose radio is shown in Figure 1. It can be seen from Figure 1 that the outrage probability decreased with the increase of signal to noise ratio. 3.2 Analysis of results. The outage probability of the method in the paper is lower than that of the cross-layer method based on supporting mixed service transmission and the cross-layer method based on multi-priority single threshold access. About 42% and 63%. This is because this method used improved AntColony algorithm to perceive the stability of reliable transmission paths of UAV AdHoc network. Selects the communication mode with the best channel conditions for data transmission, and also use dynamic congruence detection in advance in congruence control of effectively reduce eruption. 4. Conclusion. In this paper, the improved AntColony algorithm is applied to the design of reliable transmission across layer method of UAV AdHoc network. The improved AntColony algorithm is used to calculate the path stability between the source node and the destination node of the AdHoc network. According to the calculation results and the running speed of AdHoc network buffer, the congregation in the transmission process is detected. Finally, through the emergent energy computation and transmission balance magnificent. The route selection process is data transmission between UAV formation is improved to achieve reliable transmission. Experimental results show that this method can improve the performance of UAV AdHoc network to a certain external and ensure the reliable of communication. However, there are still rare areas to be optimized in this study. In the future research, we will consider the throughput in the data transmission process, obsess the cross-layer cooperation, and improve the network throughput on the basis of ensuring of the original delay and deliver success rates. Acknowledgement. School-level project of Beijing Politics project name research on control system of merely as XM unnamed area vehicle with constant speed and variable pitch.